All right, let's talk about a word you've probably heard a million times by now, blockchain. We're going to cut through all the hype and really build this idea from the ground up, piece by piece, kind of like you see here. Let's dive in.
First things first. I know, this topic can sound super complicated, but I promise you, it's way more straightforward than it seems. I mean, look, if these little sea otters figured out how to use rocks to crack open their dinner, we can definitely crack this one open together.
So what is a blockchain at its absolute heart? It's something called a distributed ledger. Now, ledger is really just a fancy word for a record book. But distributed, that's the magic word here. It means this isn't one person's book tucked away in a safe somewhere. No, it's a shared database, with copies spread out across a whole network of computers that all have to agree on what's inside. There's no single boss in charge.
To make that a little more real, think about it like this. Your bank account? That's a traditional ledger. It's centralized. The bank controls it, you can't see everything, and you just have to trust them. A distributed ledger, on the other hand, is kind of like a shared Google Sheet. Everyone who's supposed to have access gets their own copy, any changes are visible to everybody, and no one single person can just go in and change things without anyone knowing. But what makes a blockchain so much more secure than a simple Google Sheet? Let's get into the secret sauce.
Well, the incredible security of a blockchain really boils down to three key ingredients. These are the things that turn a simple shared document into a basically unchangeable chain of records.
Here's how it works. First, a bunch of recent transactions get bundled together into a block. You can just think of this as a new page in that record book. Then, that block gets sealed with something called a cryptographic hash. The best way to think of a hash is as a unique digital fingerprint. It's created by a complex math problem, and if you change anything in the block, even a single comma, that fingerprint changes completely. And finally, and this is the really clever part, that new block's fingerprint gets baked into the next block, creating a chain where every single block is cryptographically locked to the one before it.
And this is where our otters swim back into the picture. A blockchain is a lot like a raft of sleeping sea otters holding hands so they don't drift away from each other in the current. Each block is securely holding hands with the one before it. So if you wanted to change an old block way back in the middle of the chain, you couldn't just change that one block. You'd have to break that link, and then every single link that came after it, all at the same time across the entire network. And that is what makes it so incredibly secure.
And all of that secure chain of hands, leads us to the technology's real superpower, immutability, which is just a fancy way of saying that once a record is written, it really can't be changed.
So let's just put it all together. You take those three ingredients, the blocks, the hashes, and the chain, and what you end up with are these core properties. It's decentralized because that record book is everywhere. It's transparent because anyone can look at it and check the work. And it's immutable because of that powerful, unbroken chain of cryptographic links.
Okay, that's all really cool technology, but what's the point? What problem does this actually solve? Well, the whole structure we just described allows two people who have never met, who don't know or trust each other at all, to send value directly to one another without needing a middleman like a bank or a credit card company to make sure everything is legit. And that is the big breakthrough.
But, like any technology, blockchain is not a magic wand. It's not the solution for everything. So let's do a little reality check. What is it actually good for? And, just as importantly, where does it fall short?
They are absolutely fantastic at that trustless value transfer we just talked about. They're great for censorship-resistant transactions, and with something called smart contracts, which are basically little programs that run on the blockchain, they can create what some people call programmable money. Plus, you get a totally transparent record book and a financial system that never closes, running 24/7 all around the world.
Now, for the flip side, they have some major trade-offs. For one, they can be pretty slow and have a hard time handling lots of transactions. It's this classic problem called the blockchain trilemma, where it's hard to be secure, decentralized, and fast all at once. Frankly, they're also terrible databases for most things that aren't about money. The user experience can be, well, let's just say it can be really tough. And some of the big chains, like Bitcoin, use a whole lot of energy.
And here is probably the most critical thing to remember. A blockchain guarantees the integrity of data. That means the record you're looking at has not been messed with since it was created. What it does not guarantee is the accuracy of that data. For instance, you could use a blockchain to track a diamond from the mine to the store. The blockchain will perfectly secure the record that someone said the diamond was from Canada, but it has absolutely no way of knowing if that person was lying. The old computer science saying, garbage in, garbage out, is still 100% true.
So all of this leaves us with a really big question to chew on. This technology proved for the first time that you could have a system for money that doesn't rely on a central bank or government. So if you don't need a central authority for money, what else might not need one? That's today's catch. Now it's your turn to go crack it open. Thanks for tuning in to this explainer, and remember to stay in the raft.